A voltmeter is an extremely useful tool to own. However, it doesn't do you a lot of good if you don't know how to use it. With this one piece of equipment, you can safely check AC and DC voltage levels, measure electrical continuity and resistance levels, which is the electricity's ability to move from one point to another, and some meters can even measure the amount of amperage being used within a particular circuit or give temperature readings. If these terms sound like some foreign language to you, visit ApplianceAssistant.com's electricity section for a better understanding of these basic terms and how electricity works. In this video, I will be covering how to measure resistance levels and check for continuity. First, a bit of safety. It is always wise to read the instructions that come with your meter. Like everything these days, it's printed in so many different languages that can look a little intimidating. But there are many different styles of meters out there, and you need to know how yours works. Next, insert the meter's leads into their proper terminals. Usually they're color-coded, red for positive and black for neutral. Many meters, such as this one, have two positive red terminals, one for measuring DC and the other for AC measurements, as well as resistance readings indicated by the omega symbol. Always hold the leads by their insulated terminals, and lastly, don't use meter leads or a meter that is cracked or damaged. Even 120 volts is no joke. Getting shocked hurts, and if you're well grounded, it can kill you. Testing for continuity is very simple, and also extremely useful for troubleshooting all kinds of electrical and appliance-related puzzles. Continuity is defined as a state of stability or the absence of disruption. With electricity, it is used to describe a closed circuit or electricity's ability to flow freely. For example, a light switch in the on position would test positive for continuity or zero resistance, while in the off position the same switch would have no continuity and infinite resistance. Contacting your meter's leads together with the meter's dial set in the omega region gives you a positive continuity reading with zero resistance. If you want to have any chance at an accurate resistance reading using an analog meter, the zero resistance value will need to be calibrated. To do this, contact the meter's leads together and use the small dial located on the side of the meter to make your adjustment. Now that the meter's zero value is set, you're ready for testing. This is also important. When testing a component for resistance, you must disconnect its power source. The presence of current when testing for resistance will likely damage your meter or blow out its internal fuse, which, by the way, is replaceable. Secondly, disconnect all connecting wires in the component being tested. Attached wires can give a false positive reading for continuity, allowing voltage to flow around the component being tested in a parallel circuit. Mistakes like this can waste huge amounts of time as you pass over the true cause of a problem and continue to look. A transducer is a component that changes one type of energy into another. This is almost always accomplished with some form of a resistor. Just like a water wheel placed in a river to grind grain or generate electricity, the paddles of the wheel apply resistance to the flowing water, causing it to turn. For example, a heating element applies resistance to electrical flow and creates thermal energy. A motor is often made up of large amounts of insulated wire wrapped in very tight windings called coils. The extensive length that the electrical current must travel within these coils creates resistance and a magnetic field used to create kinetic energy in the form of motion. The correct level of resistance is important for a particular component to function properly. A small motor, for example, may require several thousand ohms of resistance, while a water valve solenoid may only require a few hundred. For an accurate resistance reading, you must have your meter set to the proper scale of measurement. You may find scales from 200 to 20,000 K, or 2 million. This water valve solenoid measures 190 ohms of resistance. Let's adjust the sensitivity setting on the meter and see what we get. On the highest scale, 2 million, I can see that electricity can flow but no resistance is detected. We drop 10 to 200,000. 0.2 is the measurement. We drop another 0 to 20,000. We drop another 0 to 2,000. 191 is the measurement. We drop one more 0 to 200, and the decimal point moves over one more position. A component's proper resistance can often be found in a wiring diagram or a technical information sheet for that particular appliance. Set your meter to the first setting above what you are expecting to measure. Next, contact the meter's leads to the opposing ends of a component. Sometimes correct resistance levels are tight and important, such as in the case of a dryer's thermistor, used to measure temperature and communicate with a control board. or an oven's temperature sensor. The resistance value for these kinds of devices fluctuate with temperature change. As I heat this oven sensor, you can see that the resistance that it offers to the circuit increases. A connected control device, such as a control board, will measure this fluctuation. The control can then cycle the heat source on and off as needed. You will need to know the correct resistance at a particular temperature to be able to test a component such as this. Correct temperature to resistance charts can usually be found in the appliance's wiring diagram or technical sheet, generally located somewhere on the appliance. Other devices simply open or close at a particular temperature range. The key is to understand what the component should be doing and using a little logic. This bimetal thermostat is used in a freezer's defrost cycle to sense if the freezer is cold enough to need de-icing. It is normally open and closes when cold to energize the defrost heater. This is a dryer's cycling thermostat. It is normally closed and opens when it reaches a particular temperature, breaking contact to the heat source. Once it cools down, it closes again, allowing more heat to be generated. For a list of electrical components, how they work, and where they are most commonly used, visit ApplianceAssistant.com's Electrical Components section. In most cases, some assumptions can be made. If a coil offers infinite resistance, it's probably defective and needs replacement. If a bimetal thermostat or fuse offers infinite resistance when it should be closed, it needs replacement. Let's test a few things so you can get the hang of it. This water valve solenoid tests about 200 ohms of resistance. This one about 350. Both will operate properly as an electromagnet to open the internal gate. This dryer igniter should have a fair amount of resistance. However, it tests as infinite or open, so there is definitely a problem. This thermal fuse seems to have a problem on a very sensitive low scale, but remember that corrosion on the terminals or your test leads can also create resistance, so let's make sure that we have good contact. It's actually okay. I hope this video was helpful. Thanks for watching. More help videos are available at ApplianceAssistant.com.